Welcome back. Let us do the sixth question from Edexcel International Advanced Level, January 2021 P2 paper. The sixth question is from the Trigonometric Identities and Functions chapter. So let us see what it asks us to do. Show that the equation 3 sin theta cos theta over 2 sin theta minus 1 equals 5 tan theta can be written in the form 3 sin cube theta plus 10 sin square theta minus 8 sin theta equal to 0. So they are asking us to write this expression in terms of all sine terms. If you can see in this form, we do not have tan theta and we do not have cos theta. So we should make use of identities to get rid of the tan theta and cos theta from this form. So let us start using the first identity over here. For part A, the identities to be used is, first we are going to start with the tan theta. Tan theta is equal to sin theta over cos theta. This is one of the most important identities you have to remember, cos theta. So now, in the given expression, 3 cos theta times sin theta over 2 sin theta minus 1 is equal to 5. In place of tan, we are going to substitute sin theta over cos theta. Sin theta over cos theta. Now, after writing this, we have to just cross multiply the expressions. This is called as cross multiplication. So we can write it as cos theta is getting multiplied with 3 cos theta sin theta and 5 sin theta gets multiplied with 2 sin theta minus 1. This method is called as cross multiplication. Now, simplifying this side, we see that cos theta multiplies with 3 cos theta sin theta, giving you 3 sin theta multiplied with cos square theta, because cos theta multiplies with cos theta, giving cos square theta equals, here we are going to apply the distributive function. So 5 times 2 becomes 10. Sin theta times sin theta becomes sin square theta. So 5 sin theta minus 1, they both get multiplied, giving minus 5 sin theta. Now, as you can see, we have got rid of the tan theta from this form. Now, the next term which remains is cos square theta. We should somehow think about getting rid of the cos square theta. So, one more very important identity you have to remember here is sin square theta plus cos square theta is equal to 1. This is the second identity we are going to use here. So, rearranging this equation, we get it as cos square theta is equal to 1 minus sin square theta. That is by sending the sin square theta over here. So now what we are going to do is, in place of cos square theta, we are going to substitute 1 minus sin square theta. So 3 sin theta. Now in place of cos square theta, we are going to put 1 minus sin square theta. This is the substitution. Keep the right hand side the same. 10 sin square theta minus 5 sin theta. Now let us just distribute the brackets. So 3 sin theta times 1 gives you 3 sin theta itself. And 3 sin theta multiplied with minus sin square theta gives you minus 3 sin cube theta equals 10 sin square theta minus phi sine theta. Now let us gather all the sine terms on one side. So I'll be taking this term on the other side. So it becomes plus 3 sine cube theta minus 3 sine theta plus 10 sine square theta minus 5 sine theta is equal to 0. This is what we get. Now further simplifying this expression, we get it as 3 sine cube theta plus 10 sine square theta minus 3 sine theta and minus 5 sine theta are like terms. So we are going to combine them and it gives us minus 8 sine theta equal to 0. This is what was asked us to write the form in. So let us confirm back again. So they wanted us to write 3 sine cube theta plus 10 sine square theta minus 8 sine theta equal to 0. So we have got it as 3 sine cube theta plus 10 sine square theta minus 8 sine theta. Exactly 6. So here, remember one thing, there are two identities to be remembered. One is tan theta equal to sine theta over cos theta. This is the first identity. And the second identity is sine square theta plus cos square theta equal to 1. So making use of the identities, we have solved the expression. So this is the answer to part A. Let us start with the B part of the question. Hence solve for a range of minus 5 by 4 to plus 5 by 4, 3 sine 2x cos 2x over 2 sine 2x minus 1 equals 5 tan 2x, giving your answer to 3 decimal places where appropriate. So now they want us to find out the value of x between minus 5 by 4 to plus 5 by 4. Now if we look at the expression, this resembles the same expression from the part A, which was given as 3 sine theta cos theta over 2 sine theta minus 1 equals 5 tan theta. The only difference you can find out over here is they have just changed the expression from theta to 2x. That is the only difference. So in place of theta, they have just replaced 2x in this question. And we have also solved this expression as 3 sine cube theta plus 10 sine square theta minus 8 sine theta equal to 0. So to further solve this question, we are not going to use this form, but we are going to use this form because this is already in the most simplest form. So what we are going to do over here is we are going to write it as 3 sine cube. In place of theta, we are going to replace with 2x sine cube 2x plus 10 sine square 2x minus 8 sine 2x equals 0. Now what we can take out common over here is we can take out sine 2x as common out when we are factorizing it. So sine 2x is present in all the terms, so take it out, and in the bracket 3 sine square x sine square 2x plus 10 sine 2x and minus 8 equal to 0 remains. So we get two factors now. One is sine 2x equals 0 and another one we get it as 3 sine square 2x plus 10 sine 2x minus 8 equals 0. Now if we look at the expression, this resembles our quadratic expression, that is ax squared plus bx plus c equal to 0. Now to factorize this expression, I am going to use splitting the middle term. So in that we have to multiply the first number with the last number. So 3 times minus 8 gives you minus 24. Now let us start finding the factors of minus 24, which when added or subtracted together should give me a sum of plus 10. So the factors of minus 24 are minus 6 and minus 4. And then we have minus 6 and plus 4. But when we add them together, we are not going to get plus 10. We will be getting minus 2. So this is not the correct factor. So the other factor could be plus 12 and minus 2. So when we multiply 12 and minus 2, we get minus 24. And when we add 12 and minus 2, we get plus 10. So this is the correct factors to be chosen. So we are going to write it as 3 sine square 2x. Then in place of 10 sine 2x, we are going to split it as plus sine 2x minus 2 sine 2x minus 8 equals 0. So now we are going to factorize it further. We are going to take out the common terms from these two. So we have 3 sine 2x common from both the terms. So here sine 2x remains plus 4. And from here we are going to take minus 2 common now. So sine 2x plus 4 equals 0. So now we are further going to factorize it as sine 2x plus 4 times 3 sine 2x minus 2 equals 0. So now we have totally got 3 factors. So one factor was here, that is sine 2x equal to 0, and these are the next 2 factors. So let us solve them one by one, starting with sine 2x equal to 0. So sine 2x is equal to 0. So we are going to take the inverse now. So 2x is equal to sine inverse of 0. So if you put it in your calculator, we get it as, let us see, shift sine, get sine inverse of 0 equals 0. So we got it as sine inverse of 0 as 0. So we get x is equal to 0 over 2, which is nothing but 0. Now for the other one, here we have another factor, sine 2x plus 4 equals 0. So sine 2x is equal to negative 4. So let us do the same thing. 2x is equal to sine inverse of negative 4. Remember to change the range from degrees to radians, because they have given us the range in the terms of radians. So in your calculator, change it down to radians. So let us also do that. So yes, 2 and 2. Okay. So now let us do sine inverse of negative 4 and see what we get. We get a math error, showing us that sine inverse of a negative value does not exist. It will not exist. Let us now go for the third factor, which is 3 sine 2x minus 2 equal to 0. So we get sine 2x is equal to 3 sine 2x equal to 2. So sine 2x is equal to 2 over 3. We will do the same thing now. Sine inverse, so 2x equal to sine inverse of 2 over 3. Let us calculate it and check what we get. Again, remember to keep it in the radians mode, not in the degree mode. There is a small r over here. which tells you that it is in the radians. So let us take shift sine inverse of 2 divided by, we get it as 0.7297. So 0.7297. This is our 2x. Therefore, x value will be 0.7297 divided by 2. Let us check what we get. Answer divided by 2 gives us 0.3648. So we can write it as 0.365. So this is the answer. So one value of x is 0, another value does not exist, and another value is 0.365 radians. So this is the answer for the part B question.